Hello, I'm Paul Thompson and I work at the National Centre for Text Mining at the University of Manchester in the UK. Today I'll be talking about work carried out with colleagues at the University of Manchester and the UK Health and Safety Executive to develop a novel semantic search system for workplace accident reports called HSE Search. Firstly, some motivation for the development of our system. It's been carried out in the context of the Discovering Safety programme, whose aims are to develop new technologies to analyse and aggregate health and safety data from different sources around the world, and to use these new technologies to help to prevent future accidents from occurring. Given the vast amounts of health and safety data available, it's vital to have the means to access and make sense of this data in an efficient manner. The HSE Search semantic search system has been developed to enhance exploration of a subset of this data. The system is freely accessible on the web at the URL shown. Our specific focus in this work is safety in the construction industry, although it's intended to extend the system to other industries in the future. The health and safety of workers is vital on any construction project, and so risk management is a crucial activity, which aims to identify potential risks to workers at each stage of the project and to determine appropriate safety measures to mitigate these risks. An important source of information when carrying out risk management is documentation that's been produced about previous construction projects. The problem is that each project generally generates many hundreds of pages of documentation, meaning that it can be very easy to overlook important information. However, overlooking important information has the potential to make the difference between the life and death of a worker. To try to overcome such issues, we've developed HSE Search as a novel search system for construction-related documents. More specifically, it provides efficient search of over 3,000 workplace accident reports. By combining keyword search with enhanced text mining-driven functionality, the system is able to provide an interactive faceted search environment for tasks such as exploring the content of the repository from multiple perspectives and rapidly filtering and drilling down to documents have the greatest relevance to a given construction project. Let's now look at some screenshots of the interface. This slide shows the main search interface window. There are three main parts to it. The search box allows the user to enter an initial keyword query. The user is assisted through autocomplete functionality based on terms that have been automatically identified in the document collection. The results panel shows the documents retrieved by the current query. Each document is represented as a snippet which can be clicked upon to view the complete document text. An additional function is the summary button, which automatically generates a short summary of longer documents, and we'll return to this later in the talk. The content exploration panel contains three different tabs which provide different high-level views of the semantic content of documents returned by a search automatically obtained through the application of text mining methods. Users can gain insights into the content of retrieved documents and further filter results based on different types of information to locate and focus on documents of the greatest relevance to their information needs. The tab shown on this slide is the dynamically generated word cloud, which displays the most important terms in the query results as identified by the Termine tool. The screenshot shows terms containing documents resulting from a search for slipped. Each bubble shows the frequency of each term, and the size of the bubble denotes the relative importance of each term within the query results. We can see that the terms represent a range of different types of information. Very prominent is the term ladder, showing that many slipping incidents involve the use of ladders. Also prominent is the term fell, probably because a slip on a ladder will most often result in a fall. Other terms denote information such as body parts that are injured during slipping incidents, location of the incident, and the consequence of the incident. By clicking on one of the bubbles, the search can be refined to examine documents containing one of these terms of interest. The second tab in the content exploration panel is the entities tab. This shows the results of automatically analyzing the search results to locate and categorize construction-related words and phrases within documents. Such words and phrases are referred to as named entities. Categories include equipment used, type of construction activity being undertaken, body parts injured, and harmful consequences of the accident. Each category is displayed as a drop-down menu containing the most frequently occurring entities in that category in the search results. Some examples will be shown on the next slide. Search results can then be refined to retain only those documents that mention entities of interest. Automatic entity recognition is carried out by training a layered neural model on a collection of documents that we previously created, in which domain relevant entities were manually marked up by domain experts. Here are some examples of the most frequently occurring entities in different categories that occur in documents containing the word slipped. Looking at construction activities, the majority of the activities are concerned with ascending or descending. However, the list also helps to identify other types of activities where the risk of slipping has to be considered, such as lifting or unloading items. Harmful consequences of slipping incidents vary in severity from bruisings and swellings to breaks, fractures, and lacerations. This list could be used to prioritize exploration of the most severe consequences in order to formulate strategies to avoid or minimize them in new projects. The final tab for content exploration is the Clusters tab, which provides users with a high-level overview of the most pertinent topics covered in the documents returned by the search. Each cluster is represented by a set of keywords that characterize the topics covered by documents in the cluster. Clicking on a checkbox next to the cluster will filter the search results to retain only the documents in the selected cluster. We use a self-tuned descriptive clustering approach in which the set of topics is dynamically determined for each new search, and documents are automatically clustered according to these search-specific topics. The first three clusters clearly correspond to slipping incidents where a fall took place in different sets of circumstances, on a ladder, on stairs, and on scaffolding. However, the documents in the fourth cluster mention a completely different category of incident, in which slipped refers to the equipment slipping from a worker's grasp rather than the worker themselves slipping. When a document snippet is clicked upon, the full text document view is displayed. This aims to make it easy for users to locate relevant information by highlighting the named entities that have been automatically identified. All identified entities are highlighted. The different colors used for each distinct entity category make it easy to concentrate on those parts of the text that contain different types of important information, such as the equipment in use when the accident occurred, the physical environment, and body parts that were injured. As mentioned previously, for longer documents, the summary button beside each snippet displays a short summary of the document. Summaries are produced using a graph-based method whose nodes include entities and terms. We compute similarity between these nodes, leveraging the Word2Vec word embedding model train using the workplace accident reports. After obtaining a weighted graph, we employ the PageRank algorithm to rank the most representative sentences. Here we show an example of a summary screen in the interface. The complete text is at the bottom of the screen, whilst the shorter summary extracts the most important details from the report, such as the context of the accident, details of the equipment being used, and the consequences. We've performed an initial evaluation of the utility of the interface by trying to determine whether the ranking of the search results can be enhanced using text-mine information compared to more traditional word-based ranking methods. To perform the evaluation, we collected a gold standard set of relevance judgments. We did this by asking domain experts to rank the relevance of the top results returned by 20 different queries on a scale of 0 to 2. Some examples of queries, results, and relevance judgments are shown in the bottom table of this slide. In the first example, the result is fully relevant to the query fall from ladder because the result text shown is concerned with a fall from a ladder. In the second example, the result text is only partially relevant to the query collapsing trench because the text mentions a collapse but nothing about a trench. To perform the evaluation, we compared the ranking of results using two different indexing methods, indexing using entities and indexing using words using Elasticsearch. We use the expert assigned relevance judgments to calculate two metrics. P at 5 is a precision for the top 5 ranked results, and NDCG is the normalized discounted cumulative gain. The results in the table clearly show that NDCG is consistently significantly higher for entity-based indexing compared to word-based indexing. These results demonstrate that the use of text mining information results in improved ranking of query results. To conclude, we've shown that the semantic search supports discovery of information by allowing the efficient exploration of search results and by making it easy to locate information within documents returned by a search. Furthermore, the faceted search mechanism provided in the HSE Search system provides users with a more interactive search experience compared to traditional search engines. Ongoing work is carrying out usability of the search system, in which we're trying to determine whether the semantically enhanced document view can be useful within a given user scenario in terms of being able to capture the prevalence of a risk category.